finishing the hydrostatic law and the static of the fluid Pascal law. Application part next class after 2 3 classes will start. But today what we will start? Flow of the fluid or fluid kinetics. This is the second one of the fluid mechanics. First one is your static, second one is the fluid kinetics, and third one is your dynamics. So in static there is no flow. Only the pressure will be considered. In dynamics, what we will consider? Flow of the fluid, but no force consideration. Because if any fluid is flowing, there is some force will be acting on it, and that not some force, several forces will be there which causes the fluid. Normally, fluid if they are having a force of inertia force. What is the formula for inertia? Inertia force. How many times I have written this one? The forces inertia force is the resultant force of. Can you identify this one? Which force I am representing? F is force. P pressure force. Second one. Third one. Okay. Quickly tell me, if you know the shear stress is equal to minus mu dV by dy, can you convert it to viscous force? This is a viscous shear stress. Multiplied by shear stress multiplied by
1 by area.
acting area. Because area, whether lateral area or cross-sectional area, that we have to consider. So, on which the shear stress is acting or force is acting, that stress we are getting from the Newton's law of viscosity. Here, plus compressivity force. Surface tension. Okay. These all summation of forces is resultant influencing this one. After this, the fluid starts flowing. How it will be flowing? So, if it is inlet, in and let it be, this is out. So, from one point to another point, due to whatever may be the force, the fluid is displacing from one place to another place. So, when the fluid is going, definitely you are having that terminology. It is genetic of velocity. That means if some object or any fluid or gas solid, whatever means, changing its position means there is a flow, and especially we are dealing with the fluids. So there is definitely a velocity. If there is a velocity, there is the acceleration. Here. Now, what type of flow? Or all the flow will be one type. You are having one type of fluid or several types of fluid?
इस पर्सपेक्टिव में पूछ रही है, इस पाइप में एक ही टाइप का फ्लूइड है ना?
It will be one type. Why I have given this graph?
वो स्पेसिस में तो बहुत सारे टाइप.
हाँ. It overally you are seeing the displacement of the fluid from one place to another place, that is flow. So whether it's a particular type or several types is possible. Okay. Now have you seen the mountain?
पार्क्स पे देखा है.
Mountain की mountain? River? झरना और नदी. फर्क क्या है?
नदी प्लेन में प्ले करता है और झरना ऊपर से गिरता है.
वाह. Both are water, same water. The flow in the jharna and flow in the nadi, both are same water.
Different.
Right?
Different.
Water is same.
Water is the
Same water is falling and coming. So how come the flow will be different?
velocity अलग-अलग है.
How come?
In case of मतलब चढ़ने के लिए potential energy ऊपर जाता है नीचे का मतलब rapid change होता है. तो इसीलिए उसका
Sir, gravity force is influencing more and gravity force is influencing less.
हाँ.
Okay, that's why my flow will be changed. So normally, that's why if somebody wants to build here one barrier to obstruct the flow, and same river when it is available wants to stop the flow. So both will be equally tight. Both the obstructions. Why? Because one type of flow will be there, another type of flow will be there. So how we classify the types of flow? Like types of fluid. Types of fluid, we are having one category that is difference of viscosity, depending on which you will obey, that is Newtonian fluid, which is not obeyed, that is non-Newtonian fluid. Similarly, types of flow. How we classify?
depending on the velocity of the
Okay. One parameter we are saying depending upon the velocity. If depending upon the velocity, we are having two types. One is laminar, another is turbulent. Any other type will be there.
density
If it is density, then flow type will be compressible, incompressible. Any other variety will be there? Viscosity, viscous flow or non-viscous flow. It is similarly to this velocity one. Because viscosity and velocity, they are just interrelated. Viscous flow is known as your laminar flow. Because viscosity is more prominent. But how you are visualizing laminar? Layer by layer. Why they are layer by layer? Not one layer is going this way, that way. Not like this, but like this. Why?
uniformity maintain
There is a affinity between them, which is terminology is viscosity. That's why we are calling this is a viscous flow. And this type of flow normally haphazardly going anywhere or like this. What type of flow you are calling? Turbulent flow. Normally at the time of flood, you have seen that turbulence in the river. But in normal summer season, you will find out the straight wave laminar flow. Normally. नहीं आता है समझ. Have you ever do the gardening? Gardening. Gardening. पानी देना पौधों. From the pipe, water is coming. How it is look like? So, what now? But if it is fully open, then you are having your spreadness. And when you are just suppressing the or the closing the opening of your pipe, then velocity will go. And at that time you will find out a speed. That is called turbulence. But if it is glass-like structure, smoothly you can easily find out, then it will be the laminar. That means the layer to layer, they will stick to each other. They will not detach from each other. That is your laminar. Or laminar, normally we are going. If one layer is going this way, another layer is going this way, another. These are the haphazardous. Normally viscosity is not coordinated in this way. That's why we are calling it a turbulent. We are classifying either velocity or viscosity. Okay. Viscosity, density, these two parameters. Any other parameter? Pressure. So how to distinguish between the pressure? Pressurized flow, normal flow. But everywhere the atmospheric pressure will be there or not? High pressure flow, low pressure flow. That is in case of gas. Okay. Any other parameter? Okay, I am giving one character. Just tell me. Anything can be. If with respect to time it is not changing, steady flow. If with respect to time the characters are changing, unsteady. So with respect to time, it is steady. And if it is changing, unsteady. 1, 2, 3. Another 3 will be rotational flow, non-rotational, or irrotational normally we are going. Good example is there. Anybody pour the vegetable oil into the bottle from the pouch. Anybody having the experience in the kitchen. Have you seen when you are just making a small hole, how that will come to the bottom? It is like water or some rotation will be there. Have you seen or not? Yes. Next time you have to make a 30 seconds video and submit. सरसों का तेल को पाउच से डालना है बॉटल में, उसको एक लैमिनार दिखाना है और रोटेशनल फ्लो भी दिखाना है. If you are normally just treating, that will be the normal laminar flow. If just simply you press it, then it will be running. It will not speak like water. Okay, just make a video there. Rotational, irrotational. Character is space. Uniform, non-uniform. Clear? How many times will be there? Steady, unsteady, laminar, turbulent, compressible, incompressible, rotational, irrotational, uniform, non-uniform. Space, uniform, non-uniform. If I go for the dimension, what the dimension is? 1 dimension, 2 dimension, 3 dimension, 4 dimension, 5 dimension and so on. 5 dimension plus addition. But normally, unidirection only in one direction. 2 direction going mainly in this direction but fluctuating in this direction. X, Y. Going in one direction, fluctuating in another 2 directions, 3 directions. Now, all these how many types of combinations are there? 6. Classification of flow, depending upon the time, steady or static, depending upon the velocity, it will be the laminar and turbulent, depending upon the density, compressivity and incompressive flow and incompressive flow, depending upon the rotationality, rotational, irrotational, depending upon the space, uniform, non-uniform, depending upon the dimension, 1, 2, 3. Now make any combination. Steady, uniform, 2 directional flow. It's up to you. Clear? So types of flow, once you are studying, and maximum we are studying about laminar and turbulent. All others are not that much of. And here you will study first 1D, then 2D, then in application you will do for the 3D. If you are jumping into 3D, you will that. One example I am giving. How many of you have known the vector? In mathematics there is vector. Velocity can be split into how many directions? If you are considering all these 3 for the main velocity, then 3 direction flow. If you consider only one directional flow, like this velocity, acceleration, all will be defined because everything will be the function of and timing. Clear? Remember the types of flow. How we are classifying this one? Recording the line. Now, so once you know the types of flow, after this what you will do? You have to imagine there is a flow. So for the fluid has to flow, a system is required. What type of system I will? Any system where the flow will be up. Tell me that. Easy example is pipeline, no? inside this pipe, your flow will be going up. Clear? Now, how much flow will be going up? How will you tell that? How much flow is going?
A into B.
Any material is in and that material will be out. Let it be 10 kg per second. 10 kg is in, 10 kg also out, or 1 meter cube per second. Like this, you can express. Now, this one we are calling volumetric flow rate. Volume with respect to time, rate of volume. Mass flow. Both are dependent or independent. One we are noting m dot, another is we are noting u. Both are interrelated or not? How?
1 meter cube is 10,000 cc.
So this is a equation. Now this volumetric flow rate, which is the velocity multiplied by cross-sectional area. Whether you are getting this unit or not. So that means that Q is equal to A into B. Cross-sectional area, remember, shear stress is acting on the lateral surface, flow is in cross-sectional area. Area multiplied velocity. And this one, just take a pulse, not you. This velocity, what I am writing, let it be 1 meter cube, the area will be 1. So what will be the value of velocity? 1 meter cube per second, area is 1 meter square. So what should be the velocity?
10 meter per second. Around
1 meter cube per second is the volumetric flow rate, 1 meter square is the cross-sectional area. What should be the velocity? 1 meter per second. Now tell me, in this total cross-sectional area, which layer will be in 1 meter per second? Which one?
middle one.
If this one is 1 meter per second, so that is the maximum one. And where is the minimum one? At the solid surfaces. Why?
Well, viscosity.
No. Opposing force by the solid will be the maximum. Here also layer to layer they are getting opposite due to viscosity. But that is liquid liquid system or fluid fluid system. Here the solid system which is stationary. That's why the layer associated with this one, the velocity will be 0. 0, 1. Why you are taking this one? If you are telling this velocity is your center velocity. Center velocity means it's a maximum one. Because as from the center we are going to the circumference, not upward. This is circle. Going upward, velocity is reducing. So all the particles are not, or all the fluids are not flowing with this velocity. Why you are taking that velocity? That means this is not this velocity. On an average, this total, whatever the velocity they are flowing, that velocity will be this one. That means this velocity is not 1, it will be something that will be 1.5 meter per second. And somewhere 1 meter per second will be there, somewhere 0 will be there. So on an average, we are taking this velocity. Always remember, this velocity known as your average velocity. Here 1.5 is a maximum velocity. Among all the velocity, which one is the maximum, that is maximum velocity. Minimum velocity, that is 0. Clear? That means 1 is your point velocity, 1 is your average velocity, another is minimum velocity. If I am asking you, what is your mark in first year course? Mathematics. Second semester. 7. CGPA 7. Great. That's a CGPA 7. What is the CGPA? 8.8. CGPA. These are the examples of points. Individually point I am just picking. Now, which one is the maximum
ज़्यादा दिख रहे हैं।
Who are the maximum? Just raise the hand. So maximum is 1. Point are several. What is your average CGPA of the class? How you are finding out the average? That is the mean. Normally you are finding out number average. But here some average we are having different formulas that we will explain in later. So among these all velocity, different numbers are there. What is the average number that we put? That is for your average velocity. Never this one is the maximum or the minimum. And what is the difference between the point? Any point, what is the velocity? Then it may be 0, it may be maximum, it may be some value. That is the at any particular point, what is the velocity? And among these all streams, which one is the maximum that we are finding out? And surprisingly, for the 5 flow, at the center it will be maximum velocity. At the center of which line is going, which fluid line, that is the maximum velocity. So any other point you choose it, point velocity. Overall, whatever the average of this one, that is called your average velocity. So whenever we are putting in the formula Q is equal to A into V, we are putting the average velocity. Clear? How many of you have known conservation of mass equation? Conservation of mass. It is not the engineering. Mass in
equal
conservation of mass. So what is the conservation equation? This is the ideal equation, remember. But somewhere you will extend this equation accumulation. That means with respect to time. A powerful equation will be there, continuity equation, which will derive from the conservation of equation. That is A1 B1 is equal to A2 B2, which is your volumetric flow rate. This equation today I will derive and use I will show you. So how to derive this equation? Take any system. One direction flow I am considering for easiness. Let it do. So here Q, the same Q will be out here. Now, what is the mass in?
Rho dV.
Rho A. Normally A V. And always remember V is the average velocity. Here, the mass will be same or different?
Same.
Same. How can you guarantee?
If the fluid is incompressible, then
Because nowhere the leakage will be there or not sticking to there. Whatever the mass is, the same mass will be out. Let it be rho plus d rho, A plus d A, B plus dB will be your additional changes. Now mass in and mass out both has to be equal. So how it will be equal? Rho AB is equal to rho plus change in density. Because after section A plus dA, B plus dB. First multiply these two. What is the value you are getting?
rho A plus rho D plus rho D.
B plus dB. Now, again you multiply. Last. What's my 0 B A plus 0 B A B. This one. Now find out where the multiplication of two differential terms is negative because very small, and if 3 better you negative, and this one negative, this one negative. 1, 2, 3. Understood? Now, this one and this one gets cancelled. So that implies 0 is equal to rho A B plus rho B B A. This all is not an expansion of what? Now, if it is in differential form, integrative. What does it mean? Rho 1 A1 B1 is equal to rho 2 A2 B2. That's all. Alternative equation. If the flow is incompressible, so what should be the continuity equation? These two will be cancelled. Understood? If processional area is equal, A1 is equal to A2. That means so whatever the velocity at the inlet, same velocity at the outlet. So like this you have to interpret this equation. But what you have to interpret, I understood this equation. Now, suppose 10 meter cube per second, the flow is there, and this diameter is 5 centimeter, and this diameter is 2 centimeter, and this one is your 3 centimeter. Find out the flow rate of this one and this one. If this is Q.
Q2 will be better than Q2.
First equation is Q1 is equal to Q2 plus Q3. So how will find out this one and this one is how much?
8 Q1 is equal to
This is a short question for the gate. Now I am giving you 1 day time, solve it and give. Here, the structure will be this one, 10 meter cube per second with 5 centimeter dia, and bifurcation of 2 only, one is 3 centimeter and the 2 meter. Find out the Q2 and Q3. How much? 4 meter cube per second and 6 meter cube per second. Okay, let's check in the next class whether that is the right answer or wrong answer.